If you follow my channel at all, it'll come as no surprise that I'm a big fan of DOF Reality's H3 motion platform. I do most of my aviation from here, and I wonder if you can notice what's changed. And no, it's not Next Level Racing's HF8 haptic seat pad, and of course I've still got Moza's force feedback yoke. I wouldn't be without it. But I have removed Moza's AB9 force feedback base and flight stick and replaced it with Moza's brand new AB6 force feedback base and flight stick. And in this video, we'll have a look at what's different. But what I can tell you right now is it's smaller, it's lighter, and it's considerably less expensive, thus bringing the world of force feedback to more flight simmers out there. Oh, and the throttle quadrant, yes, that's new as well, and we'll cover that in a future review video. Welcome to your Flight Sim channel. My name is Mark. Thanks very much for watching, and let's get started. Don't get me wrong, I still love the AB9 force feedback base. It's amazing, and I've moved that to my static rig. Today we're looking at the AB6 bundle, which includes the force feedback base, the MHG Flightstick, and a desk mount. I'm not aware at the time of making this video if items will be available individually. Let's take a quick gander at what you get. We'll have a look at pricing, then test it out in Microsoft Flight Simulator 2024. AB6 comes with its own power supply and is considerably smaller than the ones provided with the AB9, encased in a plastic composite. Connection is via USB-B and USB-A to the hub or PC. The desk mount requires assembly, is made out of solid metal. It's a steel alloy, fairly weighty and clearly built to last. Once assembled, it's attached and held to the desk with two metal clamps, which once again are predominantly metal. We'll look at this in a little bit more detail, but first of all, let's have a look at the MHG Flightstick. To compensate for the reduced height of the force feedback base, it has a longer neck than what we're used to. Unlike Moza's MH16 Flightstick, which is a combination of metal and carbon composite, this has been designed with weight in mind, keep it as light as possible, and consists mainly of a carbon composite, except for the attachment screw housing at the base, which features Moza's standard 5-pin connector. On it you'll find all the buttons, hat switches, two-stage trigger, and POVs that you would expect to find on the joystick. It's right-hand only as far as I'm aware, seems well put together and nicely finished, but certainly has more of a budget feel to it than some of the other offerings from Moza. The flight stick itself is very comfortable and nicely molded and fits nicely in your hand. There is, however, only limited adjustment possible in terms of the palm rest, and you can effectively lower the palm rest simply by removing this add-on portion here. As far as I can tell, no other possible adjustments are available. The overall size is such that it will suit medium to large hands. And now to the main event, let's have a look at the AB6 base itself. From a size point of view, let's just compare it to the AB9. And as you can see, there's a big difference indeed. Like the AB9, it has a metal outer casing, but not as heavy duty as that found on the AB9. Having said that, it's fairly weighty, and again nicely finished. As per the other Moza flight peripherals, it features not only its own power supply, but you're able to daisy chain various peripherals via the RJ11 connectors, and as mentioned previously, a USB connection. In addition to the desk mount, various mounting options are available through the various screw fixings on the base of the unit. Unlike the AB9, it features two additional axes, one labelled as slider and the other as dial, as well as 8 programmable buttons, labelled 1 through 8, 4 on the left, 4 on the right. Movement of the centre spindle is free and easy, and I can feel it moving against the metal cogs. Assembling the flight stick to the unit is straightforward. Remove the protective collar. We don't need that anymore. The cable in the flight stick has a little bit of play, so just pull it out to make connection easier. Push it firmly into place, making sure the pins line up and fully tighten down. And your flight stick is connected. The extended neck of the joystick does make it feel a little bit top heavy. Makes sense now why it's made out of a carbon composite, but once assembled it matches the same height as the AB9 with the MH16 joystick attached, as shown here. The advantage being that it eliminates the need for an extension neck. With regards to compatibility to third-party flight sticks, I can only assume at this stage it's pretty much the same as the AB9, but I haven't tested this extensively, And whilst I think it'll be absolutely fine with something along the lines of Virpil's Alpha, Thrustmaster's Warthog, which is all metal and a heavy flight stick, whilst compatible in my tests, I think this flight stick would be better suited to the AB9. Right now, you're probably wondering exactly the same thing I did at this point. Whilst this is considerably less expensive, and we'll look at pricing in a moment, how big a compromise is it? The AB6, as the name implies, delivers 6 Newton meters of force compared to the AB9's 9 Newton meters. When used in flight sim, how meaningful a difference is that? Well, we'll check that out in our test just now. The all-metal body construction is not to the same level as the AB9, obviously designed for a price point, but the steel body in conjunction with the aluminium base still makes it a sturdy construction. The drive motors within the unit are obviously considerably smaller than the AB9. Now turning to the important topic of price, please bear in mind that this video was made pre-release, so as always, check the Moza website for confirmation of prices in your local currency. For a like-by-like price comparison with the AB9, if we were to take the AB9 base plus the MH16 joystick and the available desk mount, the equivalent price would be £687, or your local equivalent. So overall, the AB6 is about 40% less expensive than the AB9. Unlike the AB9, the AB6 base has a built-in Z-axis or rudder axis. So if you're not using rudder pedals, no problem. If you are using rudder pedals, you do have the option to lock off the Z-axis. Simply insert 2 screws here, one at the front and the other one at the rear. This will prevent the joystick from moving through that axis, but I'm pleased to see that the twist has been included as standard. Assembly of the desk mount is fairly straightforward. The 2 clamps are simply bolted to the metal support. All nuts, bolts, tools, etc. are supplied with the AB6. I've now installed the base plate, and to that we can attach the AB6. It can be mounted in a number of different positions on the base plate. The only important thing is make sure that you leave enough room to attach your power cable, USB and so on. There is a limited amount of height adjustment that you are able to achieve with this desk mount. A variety of different ways you can secure it to the base. A force feedback device is only as good as its software, and Moza Cockpit, which is constantly being updated, is now reliable and consistent, but you will have to invest a little bit of time in order to get it just the way you want it. And the most important settings are here under the basic settings, which in a nutshell determine the intensity of the telemetry data. Pay attention to the dampener, inertia and spring settings here. Turn dampener and inertia down to increase intensity. Microsoft Flight Simulator does not inherently support force feedback, so the Moza Cockpit software reads the telemetry data from the sim in real time, and there's a wide variety of different aspects and features that can be enabled. Note, not all are enabled by default, so when first setting up, make sure you run through these and enable the effects that you want, covering such aspects as engine vibration, stall, turbulence, flaps and gears and so on. There are separate settings for jets and helicopters. Within the software itself, it's also a good place where you can check all the axes and buttons, dials, etc. operating as expected. And in addition, you can configure various aspects, such as button lighting, lighting intensity, or sync to the sim with various aircraft. One very nice and useful feature, which is becoming more common these days, is that you can determine whether a POV will operate as an axis or as a button. There is a very wide range of options and parameters that you can adjust, and I'm not going to run through all of them here. But under the special tab is where you can enable hardware trim. I've mentioned this before when I've covered the AB9, but I do get a lot of comments saying it doesn't work. Well, it does work, and if it's not working for you, you haven't set it up properly. As per the diagram shown here, hardware trim is effective on your elevators and on your ailerons, nose up, down, or left or right wing down. Now within your respective sim, you have configured those functions to various buttons, but you also have to configure exactly the same button here in Moza Cockpit to those functions. Once you complete that exercise, hardware trim will be operating fine, and I'll demonstrate that once we jump into sim. Another useful feature, and something I just want to touch on, is under the Expert Settings tab. Here you have 2 options. autopilot following, and you also have a setting for trim. If you enable trim under this setting, it disables hardware trim. This setting here is effectively software trim. I recommend you use the hardware trim as it's simpler and easier. The autopilot following option works very well indeed, but more applicable to a yoke rather than a flight stick. The software itself is fairly easy and intuitive to use, but you do have to invest a little bit of time experimenting to get the best results. Whilst not a prerequisite, I recommend you start the Moza Cockpit software and make any changes to the parameters that you require before you start your sim, including selecting a suitable profile, or alternatively create your own profile and save it. Profiles currently available for the AB6 are limited, but hopefully Moza will expand that soon. Today we're going to do our tests in Gottfriend's new release, the A32 Vixen. It's an aircraft that reminds me to some degree of the Draco, but perhaps just slightly less ill-tempered. For the AB6 base and flight stick, there is no default configuration within Microsoft Flight Simulator 2020 or 2024. But you basically configure this exactly the same way as you would for any other peripheral. Here I've done a basic configuration that will suit most GA aircraft, as well as a number of general control settings for my camera, etc. The force feedback base and MHG Flightstick are seen as one unit, making configuration fairly quick and easy. When using any force feedback device, I always recommend you go to sensitivities to adjust your sensitivities and to put in a small dead zone to cater for the vibration and to give you improved control. Okay, so it's time to get down to the nitty-gritties. The Vixen is a recent release from the stellar developers Gottfriend. If you're into bush flying and stall activities, well, you'll like this mean machine. And today we'll be testing it out in and around Osaka in Japan. Demonstrating force feedback in a video is always a difficult thing to do, as it's often more about the feel than the visuals. But to save the purists a little bit of time, yes, I've increased the intensity of the force feedback, perhaps more than what would be realistic, but I've done it for the ease of demonstration. So now we've got that out the way, I've got to say I was very pleasantly surprised at the accuracy of the feedback, and most importantly the motor tension. I was concerned it was going to be a little bit floppy, a bit loose, but I assure you that certainly is not the case. As I increase the RPM of the engine, so the amount of vibration reduces, now coming back to idle, and we've got vibration again. That's very realistic. There's no question in my mind that force feedback, well, it's unique and adds a whole new dimension to flight simming. I've added the flap axis to the right-hand slider, and as I apply flaps or take the flaps off, I'm getting a lovely vibration through the stick. One aspect that Moza have completely nailed is the aspect of ground roll. Just going to apply a little bit of throttle and get moving. Type of vibration changes very slightly, but I am on tarmac and it will register any lumps and bumps. So to demonstrate it, what we're going to do, let's head off the runway itself. Looks like a little bit of rough ground here ahead of us. I'm going to release the joystick so we can see how it reacts as we hit the uneven surface. And we can see it reacts exactly as we hoped it would, and more importantly, the latency is next to zero. Anyway, let's now head back to the runway so we can carry out some more of our tests. Feedback once I hit the level surface will reduce on the joystick, and I'll be able to feel that directly in my hands, which is exactly the case. Now applying a little bit of rudder just to line up. And once I've lined up, I'm going to stand on the foot brakes fairly harshly, come to a sudden stop. Once again, we should feel that through the joystick, and we do. The flight stick pushing itself forward slightly. Before we get up and away, it's quicker and easier for me to demonstrate the hardware trim here. Now trimming for nose down, I'm just going to add a little bit of throttle to get rid of some of the vibration. The movement of the flight stick has followed the trim input. Now trimming for nose up. The yoke and trim indicator in the aircraft are reacting accordingly and in line with the movement of the actual flight stick itself. Hardware trim fully functional. Let's start heading down the runway. Pushing the throttle forward now, we're going to gain some airspeed. This aircraft doesn't need much to encourage it to get into the air. applying a little bit of right rudder to cater for the torque, and as soon as we're airborne we're going to cut the power so we can register a hard or brutal landing. We would expect any force feedback device. Whoa, nice! We can see that it reacts accordingly. Let's just try that again, but not quite as hard perhaps. So once again we're airborne, I've cut the power, and we're just going to drop down again and watch it as it bounces along the runway. Yes, we're getting the feedback that we expect. Okay, enough tests on the ground, let's get up in the air. And we can take the opportunity to fly over Osaka. This is quite a scenic part of the world to fly in. Recommended if you haven't tried it. The Vixen bobbing slightly in the wind, I can feel it through the flight stick. Just trying to gain a little bit of airspeed. There we go, just coming over 80 knots. Now to test the dynamic forces on the aircraft, whether or not I can feel the increased intensity as airspeed increases in the spring. The faster I go, the more wind force we have, the more tension when I move to the left or right with the joystick. And whilst it's not at the level of the AB9 force feedback base, there is very significant tension. I'm impressed. Let's now try a power on stall, keeping the throttle on and sticking my nose right up in the air. Airspeed washes off. There's the shudder and the wing drops. Okay, so that's a power on stall. Let's just gain some airspeed again and we'll try a power off stall. My goodness, this aircraft picks up speed quickly. Okay, so throttle back. Let's put the nose in the air, but not quite as aggressive as last time. And we're looking for that stall feedback through the flight stick. Coming up on 20 knots now. There it is. Very nice indeed. Lots of feedback. Flight stick is shaking, yet I'm holding it fairly tightly. Well, stall functionality, it's a big pass in my book, 5 stars. Time to check out the atmospheric and turbulence reaction. Let's change to light thunderstorm. Hands off on the flight stick, and as soon as we kick into the new weather, we can see the flight stick is changing and reacting to the environment around us. Not sure what the size of the motors are, but with this increased speed, as I bank left and right, it's taking quite a lot of tension. Far more than I expected from such a small unit. Not sure exactly what magic Moza are weaving here, but it's working. This aircraft obviously doesn't have gear up and gear down, but I have tested that with another aircraft and it works just great. The telemetry for the gear and for the flaps is very well done indeed. Now turning on to final to land back where we started and trimming a little bit of nose down just to keep our airspeed. Once again, testing for the force feedback, trying to keep the speed just ahead of stall, then keep the nose level, and we should get a bit of shake in the stick as we stall just above the runway, and there it is, perfect. We're down, although a little bumpy. Overall, I've got to say the AB6 force feedback base and MHG Flightstick does a pretty good job overall, and at a price that appeals to the middle of the market. If you're looking for a general purpose force feedback device, well, this could be it. It's not as robust or as punchy or have as much kick as the AB9 force feedback base, but offers a saving well over £200 compared to the AB9. The AB6 in my book, well, it's a win. And thank you Moza for bringing this to the flight sim community. Recommended. Thank you very much for joining me today. All the relevant links in the notes below the video. Stay well, look after yourselves, see you all again very soon, and ciao for now.